Welcome to 1.1, beginning of our journey. Lines in a plane. This should be review, and here will be my expectations. If you're taking this course, hopefully we get some viewers that aren't taking this course that maybe are looking for some tips. But anyway, if you're taking this course, pretty much everything I write here I'm going to expect as part of your notes to be available. And when I refer to this one as page 1, it will be the information here. That's just kind of our rules for this section, and then it will we'll go through part of the problems from the beginning of this page. This is what I'm actually referring to as page 1 of the work. Some of that I will do, some of that you will do, as you'll see. But if you're taking my course, what I write here is just you're to copy what I write. That way I know you've listened to, you've gone through the notes section. So anyway, definition of slope of a line, which we're familiar with, but maybe I can give you a little bit of a new spin on it, is you take a y-coordinate minus a y-coordinate over an x minus x, and this could be y1 minus y2 over x1 minus x2. For instance, if I have ordered pair, let's go 4, 6, and another ordered pair 7, 10. This could be my x1, y1. This could be my x2, y2. And it doesn't matter what order I subtract them in so long as I stay consistent. If I start with 6 minus 10, I need to put that on 4 minus 7. Or I could start with 10 minus 6 over 7 minus 4. And we find out that our slope is 4/3. Now, other ways we talk about that as slope, change of y and change of x. We've got a formula. You may also see this. Eventually, a calculus term for it would be dy dx, and that dy is delta. It's for displacement. Displacement means change. So you might see it this way as well, dy dx. That's just another symbol for displacement, another symbol for d. So there we have our slope, and I realize this is review. You probably have seen this back since junior high. The slope of a line is positive if the slope is positive. As we know, if the slope is positive 4/3, let's just say we start here. That would mean we rise 1, 2, 3, 4. Change of y. Oh, by the way, this also we would call rise over run. We rise 1, 2, 3, 4. We run 1, 2, 3. And that is considered a positive slope. It rises from the left to the right. And likewise, if the slope is negative, that would be like negative 4 on 3, which means we either fall 1, 2, 3, 4 and run 3, or of course that's equivalent to 4 on negative 3. We could rise 1, 2, 3, 4, but run backwards 1, 2, 3. Okay, so falls from left to right. Just as we would think a line with slope 0 is just a horizontal line, and that kind of makes sense. And a line with undefined slope, so steep we can't give it a number. It's like slope infinity, is a vertical line. Okay, now, point slope form. My guess is that most of you at this time have spent a lot of your algebra, the beginning of your algebra when you're graphing lines, specializing in slope-intercept form. We're comfortable with that one. This formula, sometimes we'll forget it, but people don't forget the slope formula because we use it all the time. We'll take a look at this equation right here. For instance, if I had 8 equals 6x, and I asked you, or let's do it this way, 8 equals x over 6, and I asked you to solve that. I have no doubt everybody in here would know we multiply by 6 on 6, and we get x equals 48. Let's take a look back up at this equation right here. If I wanted to solve for y2 minus y1, I would multiply both sides by x2 minus x1. And I would get y2 minus y1 equals m times x2 minus x1. And take a look what we have here. A y coordinate minus a y coordinate equals slope times an x coordinate minus an x coordinate. If I multiply by x2 minus x1, if this comes over here, I get a y coordinate minus a y coordinate equals slope times the x coordinate minus the x coordinate. To be perfectly honest, this is probably the more useful form for us, but this is a wonderful form for graphing, and a lot of times in real world situations we really want to know what the y-intercept is, because that might be like when time equals 0. Where were we, how many miles down the road were we when we started our journey? We started our journey at time equals 0. Okay, summary of equations of lines. We've got general form, which we will use very, very seldomly. A vertical line, and this causes people problems, so let's pay close attention to this one. A vertical line, let's say we're right here. And there, this is the y-axis, x-axis, and then we have this line right here. I promise you, I made this mistake. I'm like, well, it's vertical, it's going up and down, so it must be y. But take a look. Every point on this line is to the right 3. If every point on this line is to the right 3, then x is always 3, and y can be anything at once. So that is vertical line is always to the right or always to the left the same distance. That's controlling the x. Horizontal line controls the y. All of the points on this line are up 7. Let's say 7. So the y value on all of these is 7. Slope intercept we talked about. Point slope we talked about. Parallel lines should make sense if the slopes are equal. And perpendicular lines, the slopes are opposite reciprocals. It'd be nice if they were just reciprocals or just opposite, but let's think about this for a minute. Here's a pretty steep positive line. If I draw a perpendicular, one's going up, the other one's going down from left to right. But let's go even steeper here. Steeper and up, flatter and down, because this one's steep, this one's flat. If this was slope 5, this can't be slope -5. That's the reciprocal playing into it. It goes down, but it's flatter in relation. So opposite reciprocals of one another. Okay, so here's my friend Eric Clapton. Not really my friend, but the great album and a great backing for what I do. You'll probably see a lot of him. Excuse me. Okay, so the general thing that we'll be doing, the general process we'll be using, I will typically do the evens, and there will be a problem you can model exactly after that, like it, and this will be kind of considered the notes, and this will really be considered the homework. I want everything that's done to the left to be very similar to how the problem on the right was addressed for these. Okay, you'll certainly have time to kind of think on your own, but we're going to kind of be in the same process. That's really going to be helpful for us right now as I'm creating this video. I don't know what situation we're going to be in the fall, and I'm creating all new videos for this. Might use it in a regular classroom setting, but specializing in, in the event that, hey, maybe we have some distance learning to do, which is probably the best thing to do with the videos anyway, because my intention in the videos is in the event you do miss class, you're sick, you're on vacation, you've got a volleyball tournament, whatever it may be, you can follow along, and so probably this works out really well. Find an equation of the line that passes through the given point and has the indicated slope, and then sketch the graph by hand. Use a graphing calculator to verify. You may do that if you'd like. It's not a bad idea. You'll find that typically what we do in this class is if it says solve it algebraically, check with calculator. we'll just do the first of those. But not a bad idea to do both. So here's why I had said earlier that point-slope formula is a great formula for us to use. Just going to jot it up here. Y minus y1 equals m times x minus x1. And that's just y minus a y coordinate equals our slope times x minus an x coordinate. Well, here's an x coordinate and a y coordinate. So this could be like x1, y1. And here's our slope. So these are just puzzle pieces. I need this piece, and this piece. Y minus the y coordinate 6 equals -3 times x minus the x coordinate, x minus -3 plus 3. And you'd say, well, it's easier to graph if we get it in slope-intercept form, and that may be slightly true, but maybe not as true as you think it is. If I just had this, I would know that I refer to it as the most interesting value of y is 6. It's what makes this 0. You'll hear me talk about the MyVox, most interesting value of x, and MyVoy a lot, most interesting value of y. Most interesting value for, even if I can't see this, for y is 6, for x is -3. That implies that the y coordinate that this passes through is 6 and x is -3. So if I wanted to graph that, 1, 2, 3, 4, 5, 6, x is 6, or y is 6 when x is -3. And then our slope is -3. That's -3 over 1, down 3, right 1, down 3, 1, 2, 3, right 1, down 3, right 1. You want to change that into slope-intercept form to graph it? You're welcome to do that. However, watch 28 without even having an equation of a line. I don't need this in slope-intercept formula to graph. I know I'm left 2, down 5. That's a point on the graph. And I know that graph is going to rise 3, 1, 2, 3, run 4, 1, 2, 3, 4. It looks like that. We don't need to have it in slope-intercept form to get a graph of it. We can have it in point-slope form. Y minus the y coordinate. So that's y minus -5, y plus 5 equals slope 3/4 times x minus -2, x plus 2. Now there is a very reasonable chance that your back of the book answers or the solution guides that I'll have available for you on the website have these in slope-intercept form, but the problem doesn't ask us to do that. And if you're taking the AP Calculus test in a year and a half from now, there's nothing sacred about slope-intercept form. If it's asked for, great. If they ask you for an equation of a line, just give them an equation of a line. Of course we could do this. We could go y plus 5 equals 3/4 x plus 3/4 times 2 6/4 or 3/2. Y equals 3/4 x plus 3/2 minus 5. 5 is 10/2. Y equals 3/4 x minus 7/2. But we had an answer that was satisfactory right there. Okay? So just something for you to think about. Now, when you get an undefined or a 0, and I'm glad we have one of each of these for me and one of each of these for you, I'm going to highly encourage that you just start with the graph. So -10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and up 1, 2, 3, 4. Slope undefined, so steep we can't even come up with a number for it, is like this. And I'm going to be perfectly honest. I'm going to tell you all the time what I think are the most common errors. And here it is in this section. The whole section, what's missed most is, well, I don't know, is it x equals -4 or is it x equals 4? Well, let's see, it's vertical, so it has to do with y. Nope. All of the points on this line are to the left 10, and x is right left. If all the points are to the left 10, x is always negative 10. That is not something you want to memorize. I'm going to talk a lot about that in this course. We want to understand things because memorization will fail, and I bet everyone in here is aware of that in mathematics. You memorize something and then, oh my gosh, I forgot the formula. We tend to not forget understanding. Okay, 2.3, somewhere here to the right, down 8.5, somewhere down here. Slope is 0, it's flat. All of the points are down. That's a y equals. All of the points are down 8.5. Okay. And one little word problem to finish this. The median player's salary for Dallas Cowboys was $348 in 2004 and $555,000 in 2013. Write a linear equation giving the median salary y in terms of the year x. Then use the equation to predict the salary in 2019. All right, some sneakiness there, but these are just ordered pairs. In 2004, we had a salary of 348,000. I shouldn't put a comma there, but or maybe I'll just emphasize this one. And then in 2013, we had a salary of 555. So I've got 2 points. I ought to be able to come up with a line here. So our slope is the y's changed to, and I can put either y first. I'm going to put the beginning one. 555,000 minus y minus y 348,000 on 2013 minus 2004. Big numbers, but you can have a calculator on this if you feel the need for that. So let's see, the zeros are all going to stay zeros. To get from 48 to 55,000, I've got to go up 7,000. To get from 300,000, 207 over 13 minus 4, 2009, and there is our slope. So our formula could be y minus a y coordinate, 348,000, equals slope times x minus an x coordinate, 2004. It says then use the equation to predict the salary in 2019. So that's going to become y equals 207,000 on 2009 times, I want the year to be 2019 minus 2004, and I'm just going to add the 348,000 to the other side. And at that point, you'll just take that into your calculator, come up with a value for y, probably round it to the nearest penny. So there you have it. That is page 1. I'm going to do these in pages, and my intention for these pages are going to go quicker because this is our first assignment. I'm just kind of trying to get a feel for. So right now you should have all of this shown and a calculator answer here. And my intent on this, I'm calling it one-page math, is that at this point, before you go on to look at the other videos from this section, you would just go back and handle 25 through 33, and just take a little bite out of this each day. You'll hear me talking about Pac-Man a lot. The old game Pac-Man, and had this little, when Pac-Man went running around, there were little circles, and Pac-Man was just eating the circles, and it was just waka 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 waka. And you'll hear me talk about waka waka waka. We just want to take little bites at a time. We don't want to try to do everything. We don't want to try to wait till, I mean, some of you in here have done this. You waited till the night before the test. It's like, okay, I got to rememorize all this stuff. No, we want to take little bites at a time and really shoot for understanding, and that's going to be a big emphasis of this course. So that is 1-1. There are certainly more pages on this. Hopefully they're sequential as you look at them, but on YouTube, but they also should be in order on the web page as well. So best of luck to you, and make certain you're asking questions, and we will see you soon.